see my grouping here. I see we have 18 students tapped in. It can be better. There's so many others that have accepted that are not here. But be that as it may, I will be commencing now, and I'd like for you to in your link, but okay, I will open it from my side. I will open it from my side and go into the first drawing. Open the first drawing that you can see. Okay, that drawing might be a little small, but I will increase that drawing in size. Can you all see that drawing on my screen? You're welcome to follow on your own computer too, but you're welcome to also have a look at what I have here. Can you see the drawing that I've uploaded here? RC001.
Yes, sir.
Bark excavation drawing. You see that?
Yes, sir.
Yes, sir.
Okay. Now, what will we be doing? We will be measuring the bark excavation. You've done bark excavations in your third year, last year. We've done mensuration in your first year, a couple of years ago. You've done that, and now we'll be continuing further, and by working out the volume of material that needs to be excavated for this drawing. Now, this particular section that we're doing now will refer to different types of excavation. In third year, we dealt with the average method, and we've also dealt with the weighted method. Now I'll be adding another one to your arsenal, so that when you're out there, that you'll be able to work through, that you'll be able to deal with this. And the one method that I'll be looking at now would be Simpson's rule. I'll just, if you'll allow me, just to close this here quickly, and then I will just the worked example, and this is what you should see in the worked example. On the worked example, you would see here that it says here the method would be the Simpson's rule. Now, what does Simpson's rule say to us? So I'm just going to have a look at what Simpson's rule says to us, and look at the formula of what Simpson's rule says. Simpson's rule says that it is D over 3. And what is D? D, I'll just go, my apologies, I have to now go in and out through this now. Get back to the drawing. If I look at what D is, D refers to the space between the respective levels that we have. That 10,000 there would be D. That is 10,000 would be D. So it tells me that the spaces between each of these levels that we have there is 10 meters. So if that space is 10 meters, it also refers, and that it would tell me, because if I look at this drawing in totality, I so much wish that I could have given these drawings out physically so we can follow it. In totality, you then look at 10, 20, 30, 40, 50, 60 meters across, right? And the other way would be 10, 20, 30, 40, 50, 60, 70 meters across. Is that what you see? Because if the space between is 10 meters, then it will be in equal blocks. You guys have done site survey, and it will be in equal blocks, and it will be 10 meters space from each other, all the levels there. So we are tasked to determine, to measure the bulk excavation to a reduced level of 4720. There it says the reduced level is 4720. We need to measure that to reduce level 4720. There's no need for us to measure risk of collapse. And we would look at what the standard system says, to us with regards to the bulk excavation. We will have to work through this, and the standard system tells us that we measure risk of collapse is either measured in bulk or in trenches and holes. It's either measured not exceeding 1.5 meters deep or exceeding 1.5 meters deep. But in this instance, there's no need for us to measure risk of collapse because we will just want to work down to our lowest point, which reflects here as 4720. It gives us this point in the bottom in here. So when I go and I look at what the formula says it is D, which is the 10 meters, over 3, that's the formula. Sum of all the first and the last coordinates, it will be the sum of 4720 and 4900. It also says that 4 times the sum of the uneven coordinates. Now what is uneven? If this is the first one, that is an even. This is uneven. So A3 and A5 are the uneven coordinates. And then plus 2 times the sum of the remaining coordinates. So it will then be A2, A4, and A6. That will give us, that's the formula for Simpson's rule. But when we calculate these, and if you go, when I go out of this, this is where I want you to form a part of it, and where I need for you to follow what it is I'm doing. And I will quickly close this. I'll quickly close this and then just upload where I have, if you look at the section that I have shown you, there are no dimensions given to us in there. There are no dimensions given, but I will upload for you, I will upload one that reflects the dimensions, but that is my own calculations that I have here. Can you see my screen? Does my screen show up here?
Yes, sir.
You can see my Excel spreadsheet.
Yes, sir.
Okay. Now, when you see the Excel spreadsheet, I will just slide down and I will just reflect on what it is that I have done here. Remember the formula says that it is D over 3 and D is 10. And it then says it is the sum of the first. It is the sum of the first. Oh, no, that's the wrong upload that I have here. Because this one here is my average method one. No, so it says it is the sum of the first and the last. Let me just go out here quickly, guys, just to get my. No, I uploaded the very wrong one. Just need to. wish I could now just write, but I can't find that one now. But needless to say, I will get back into that and just upload that spreadsheet again. Okay, you can see my Excel spreadsheet. Okay. When we say our description would then read bulk excavation, impeccable material and open face to reduce levels, and extra over excavation for carting away surplus excavated material. And I would want to extend that. And what would we say there? I need to state there to a site selected
By
Right.
contractor.
the contractor.
Yes, there we can see your screen.
But I'll say there, to site selected by the contractor. That is what your description would look like. Or you might get told that you need to work out away 3 kilometers or so,
Yes.
to a site 6 kilometers or 3
So is
kilometers away. But when dealing with the Simpsons rule, what we would do, when looking at the drawing that you can see, is that we would then add, for the first and the last, we would add each and every dimension moving, going through.
Mr. Joy,
Hello, yes?
sorry to disturb you, sir, but the hands are up. Can you?
Oh, thank you, guys. Remember, I cannot see when there is a hand up. When I have, okay, I see a hand. Anybody who wants to ask a question? I do not see any hands now. Okay, Sitelo. Okay, and there's Nomta, and then we go to Odwa. Okay, Sitelo first.
The Excel spreadsheet is not clear. We can't see anything there.
Can you not see the Excel spreadsheet?
Yeah, we
Yeah,
can
the
see it,
page
but
and
there's something there that is preventing us to see the rest of the screen.
Can you see now?
No.
Okay, I'll just stop sharing quickly. And I'll try and upload this
Like a
again.
dialog box.
This happened to me last week as well. Okay, can you tell me if you see my screen now?
Yes.
Yes, sir.
Can you see my screen, the Excel spreadsheet now?
Yes, sir.
Okay. So when we have, I'll just go back again, you see bulk excavation, and then our description saying extra over excavation for carting away surplus excavated material to a site selected by the contractor. Now, when we look at our determining the volume to be excavated using Simpson's rule, and I now have to unfortunately go out here and show that and go back to the drawing again. In going back to the drawing, we can then, I don't know if the drawing is going to show now. Does the drawing show?
No, sir. Not yet.
Can you see the drawing from your side?
No, sir.
No, sir.
Okay, you should see it now.
Yes.
Yes, sir.
Okay, it's reflecting. Right. So with the drawing, I'm now just going to show, and I'm going to count, and we said that the spaces, that D is 10. So I'm going to count and say 10, 20, 30, 40, 50, 60, and 70. So you can see my cursor moving. You can see my cursor moving. So the distance is 70 meters. So it's 70 meters, and that 70 meters, we would then have to, what we would do then is add all of these levels that we see here. We add all of them. And we then arrive at whatever the total is for the first one. And we then add whatever the total is and we divide that by 8 because there would be 8 levels. There would be 8 levels at each point. It would be 1, 2, 3, 4, 5, 6, 7, and 8. There would be 8 levels that we are given. So when we have d over 3, it would be the 10 over 3 multiplied by, because I need to determine the volume. So I need to have 3 dimensions. So it will be 70 the length, and I then have to add, so I'm just going to swap over again. See my screen?
Yes, sir.
The Excel spreadsheet?
Yes, sir.
Okay, so I have now all the levels that you see, 4, 7, 20, all of those. I add that, and then I get a total of that of 39,080. And I divide that by 8, because that is the number of 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8, it gives me 4,885. And the level that I have, my reduced level is
4720.
4720. And the difference between those two is 165.
Yeah.
And if I now go back and I'll see that would be 10 over 3, or you can have it written like this, 1 over 3 multiply 70 multiply 0.17, which is the average of all 8 of those levels on the first, on A1. You can see my reference here. My reference here shows that is on A1. So what have I done? All I've done is, and I'm going to type here quickly. All I've done, I've broken this up. As follows. I'll have D divide 3, and that multiplied by A1. Can you see that?
Yes, sir.
That's what I've done. And I said plus D over 3 multiply
A6.
A7.
A7. Oh, A7.
In a nutshell, that is what I've done. If I scroll down, you'll see A7 would show the same. A7 is everything added on the right-hand side, divided by 8, and that gives me 604, and that's 7.
Oh my God.